This video is over lesson 85, solving problems using the Pythagorean theorem, and this is for my Algebra 1 class. So ladies and gentlemen, Pythagorean theorem is something that we should already know about, but we are going to review it here today in this lesson. So I would recommend that you take a moment and pause the video to copy down what you see on the screen. Make sure that you give everything its proper spacing. I've planned that out very specifically. So the Pythagorean theorem says if a right triangle has legs A and B, and so remember the legs are going to be the two sides that make the right angle, and hypotenuse C, so the hypotenuse, remember, is the longest side, it'll be the side across from the right angle. Then A squared plus B squared equals C squared. Now a lot of times we like to simplify the Pythagorean theorem down to A squared plus B squared equals C squared because that is pragmatic. However, it is important that you remember the beginning part here, that you first need to have a right triangle before you get the A squared plus B squared equals C squared. So with that being said, let's go ahead and check this out. So first example here, remember that A and B are going to be the legs, the two that make the right angle. So that means that 7 and 4 will be my A and my B. So 7 squared plus 4 squared then must equal, and it's the hypotenuse, the longest side, the side across from the right angle that we don't know. So we'll just leave that C squared. And if we go ahead and solve this now, before we solve, let's simplify. You always want to simplify as much as you can before you solve. So I'm going to follow the order of operations to simplify this. So 7 squared is 49, 4 squared is 16, and that still equals C squared. We'll simplify that further, and so we're going to get 65 equals C squared. And now we're ready to simplify. So in order to cancel out a square, we'll need to take the square root of both sides. And when I do that, I'm going to do a little symmetric property of equality. I'm going to flip the two sides here real quick. So the square root of C squared equals the square root of 65. Now it's been a little while since we've talked about how to solve equations that have a square in them. So remember, technically, there should be a true square root here that we take. So there'd be a plus minus in front of this. However, with the Pythagorean theorem, we don't do a plus minus because we can't really have a negative side length. So the context here means that we are just going to stick with the radical, and we will have a positive result there. Over here, my square root, my square will cancel. That leaves me with just C. And then on the other side, we're going to go ahead and find the answer. And so the answer there, well, there is no nice square root of 65, so I'm just going to leave that. Square root of 65, and then since I don't know if this is inches or centimeters, we're going to write the word units as a placeholder. So this, ladies and gentlemen, right now is the exact answer. This is the exact answer. And this does have some benefit for us. So we know exactly what it is. There's no rounding here. It's not close to being true. It's exactly correct. However, this isn't very useful in the real world. So in the real world, what we would do is we'd want to round this off. Now, if you were to hand this off as an answer, let's say in a company when you're working, you could hand this off to several different departments then, and then each department could decide how far they want to round off that answer to. So, maybe one department just needs it rough and, to the nearest whole number. Maybe there's another department that needs it to the nearest thousandth. So that is one benefit of an exact answer, is it allows someone later down the line to decide how far they want their answer to go to. What do they want to round to? However, we are going to round our answer here. We're going to round it off to the nearest tenth. So if you grab your calculator real quick and go ahead and type that in, square root of 65, you should see something on your calculator that looks like 8.06225774829885, and if your calculator has more decimals than mine, then you'll see more. This is irrational. This decimal is going to keep going on and on forever. And so we're going to round this off. I'm going to round it off to the nearest tenth. So looking at this, I need to look at, nearest tenth is just one decimal place, so I need to look at 2 decimal places. So 8.06, I'm not going to keep the 6, but the 6 is going to tell me that I should round up. So I'm going to round this up to 8.1 units. So depending on exactly how far I'm looking, how exact of an answer I'm looking for, either one of these potentially could be my answer. So either the exact answer or the approximate answer. All right, let's take a look at the next example now. So remember that it is the sides, the legs, the 2 sides that make the right angle, that are A and B. So in this case, either 5 is A and we don't know B, or 5 is B and we don't know A. I kind of like to have my variable first, so I'm going to make my unknown A. So A squared plus 5 squared is going to equal the hypotenuse, which is across from the right angle. So square root of 61, and then I'm going to put parentheses around just to make it clear that I'm squaring this square root. Now we always want to simplify before we try to solve, so I'm going to do what I can here. I can do a 5 squared is 25, and then my square will cancel the square root, leaving me with just a 61. From here, this is a pretty easy equation to solve. Subtract 25 from both sides. So therefore, a squared must equal 36. If I take a square root of both sides, then a equals 6 units exactly. And for our next example, I'm going to bring that up a little bit. Here again, we see the 2 legs. So either A is 4 and B is 3, or A is 3 and B is 4. It doesn't really matter. So I'm going to do it kind of the way I see it. So A is 4, B is 3. So 4 squared plus 3 squared equals, and again the hypotenuse is unknown. That's across from the right angle. C squared. Remember, the hypotenuse is the longest side, so the longest guy is by himself. All right, so we simplify. 4 squared is 16, plus 3 squared is 9. 16 plus 9 is 25. Oop. Almost forgot my equal sign there. Do a quick square root of both sides. I'm going to do a symmetric property as well here. And so then C must equal 5 units. So ladies and gentlemen, this one is special compared to the other 2. If we can look at the other 2, I had 2 rational length sides and then an irrational length side. Same thing here, I had an irrational length side and then 2 rational length sides. But here, all 3 of these are rational. All 3 of these, in fact, are whole numbers. And so when this occurs, this is what's called a Pythagorean triple. So Pythagorean triple is any time where we find 3 whole numbers that satisfy a squared plus b squared equals c squared. So 3, 4, 5 is a Pythagorean triple. So if you have a triangle with side lengths 3, 4, and 5, so whatever the units those may be, 3 inches, 4 inches, 5 inches, it will always form a right triangle. 3 miles, 4 miles, 5 miles forms a right triangle. And there are a bunch of these. So 3, 4, 5 is a Pythagorean triple. Another one is 5, 12, 13. 5 squared is 25. 12 squared is 144. And then 25 plus 144 is 169. And well, that's what 13 squared is. Another Pythagorean triple, 8, 15, 17, 9, 40, 41. are all Pythagorean triples. And there's a whole list. You can actually do a quick Google search if you want to and see a whole bunch of them. Now, knowing just these few, you can actually find an infinite number of Pythagorean triples. Because it turns out that if you have a Pythagorean triple, any multiple of that will also be a Pythagorean triple. So if I come back here to my 3, 4, 5, if I just double each of those, so 6, 8, 10, that is also a Pythagorean triple. 6 squared is 36, 8 squared is 64. Add the two of those together, you get 100, which is 10 squared. I could triple each of those, 9, 12, 15, and so on and so on. Or I could multiply each of them by 5, 15, 20, 25. I could double each of these, so 10, 24, 26 would be a Pythagorean triple. 16, 30, 34, 18, 80, 82, and so on and so on and so on. Now we're going to talk more about Pythagorean triples in a little bit. Particularly we'll talk about the 6, 8, 10 Pythagorean triple and how that gets used. But before we can talk about that and how that's useful, we're going to flip over to the other side here and talk about the converse of the Pythagorean theorem. So if we remember back several lessons now, we talked about the converse. So a converse is when you have a conditional statement and you switch the two statements around. So what used to be the hypothesis becomes the conclusion. What used to be the conclusion becomes the hypothesis. So notice now the if part is our a squared plus b squared equals c squared, and our right triangle part is the then part. So we switch these around. So it turns out we can do this. You can't always do that, but this is one time that we can. So if you find three numbers that satisfy this equation, now this time they don't have to be whole numbers, but if you find three numbers that satisfy this equation, then your triangle is a right triangle. So you can actually use a squared plus b squared equals c squared to prove something is a right triangle. So is 8, 10, 12 a right triangle? Well, first of all, ladies and gentlemen, we're going to plug this into our a squared plus b squared equals c squared. Remember that c, the hypotenuse, should be the longest side. So when you're setting this up, you always want to set it up so that the two smaller ones are your a and your b, and your biggest one is the one by himself. That's your c. All right, so if we check this out now, 8 squared is 64, plus 10 squared is 100, 12 squared is 144. And if I add those together, 164 equals 144 is a false statement. So to correct this, I'm going to come here and make those not equal to. And since a squared plus b squared does not equal c squared, is this a right triangle? No. If we check out this next example, is 4 square root of 97 and 9 a right triangle? Well, we're going to plug it into a squared plus b squared equals c squared. So once again, we want to check out and see which one's the longest. We want to make sure the longest is by itself. So the only issue is how big is the square root of 97. You could throw that into a calculator and figure out, okay, how big is that going to be? Or you could also just consider the fact that the biggest number will also have the biggest square. So if I square 4, that's going to be 16. If I square 9, that's going to be 81. And if I square root the square root, or square the square root, that'll be 97. So actually, this is the largest. When I square it, it ends up being the biggest, which means that before I square it, it's still the biggest. So I'm going to set this up as 4 squared plus 9 squared equals the square root of 97 squared. So make sure your longest side is the one by itself. So 4 squared is 16, 9 squared is 81, and the square root of 97 squared well, those are going to cancel, is 97. 16 plus 81 is 97. So would these three lengths form a right triangle? Yes, it would. Now, I said earlier that we were going to talk about how Pythagorean triples are helpful, and that's when we use the converse of the Pythagorean theorem together with our Pythagorean triples. So in the real world, and this actually is used, let's say you're building something and you need it to have a right angle. So I want to know, did I make a right angle here? And so what people will sometimes actually do is, instead of grabbing out a protractor and doing their best to use that, they will actually measure a certain length in one direction. So maybe they'll measure, let's say, 6 feet in one direction. But then they'll measure 8 feet in another direction. So what we're trying to use here is we're trying to take advantage of this Pythagorean triple, 6, 8, 10. So if I'm 6 feet in this direction and I'm 8 feet in that direction, then if I measure the distance directly between these two marks, I need that to be 10 feet. If it's 10 feet, it forms a Pythagorean triple and therefore is a right triangle. So let's say I measure this out and it ends up being 10 feet 2 inches. Well, that just means that I need to take these two sides and I need to push them a little bit closer together to shrink that distance. If I measure them and it comes out 9 feet 8 inches, I know then I need to take these 2 points and I need to open this up a bit more. I need to slide these away from each other, these 2 points. If I move it around enough and I measure and I find out that these are 10 feet away from each other, I know then, therefore, that must be a right angle. And so you can actually use that trick in the real world to see if you've made a right angle without having to actually measure the angle. And that, ladies and gentlemen, is the end of our lesson.